Hello, this is part 2 of lecture 12. So what I'm going to do here is show you pictures of the indicators of the stock market valuation that are of interest to us. I'm going to do this using pictures that I take from a website that is called Advisor Perspectives. This is a website that offers material for people who are going to work as financial advisors for investors. And it's at dshort.com. And they update these market valuation indicators on a regular basis, at least once every 3 months. And what I like about this website is they tell you exactly how they construct the series right up here in this box. So this is the numerator. It tells you the table from which it's taking the data. This lets you know that this is actually equities of non-financial corporations. And they even tell you the code number for Fred of how you find the data in the numerator. And then, of course, in the denominator, you're using GDP. And this first indicator is the Buffett indicator, corporate equities to GDP, from 1952 to the present. And this, and they put little marks here as to where it is relative to its long run average. And you could see this is data for the fourth quarter of 2019 is as far as it goes. So it doesn't have the recent turbulence in the stock market. And it's mentioning that it's using the third estimate of fourth quarter GDP. I had previously mentioned in a lecture that every quarter they have a first, a second, and a third estimate of what GDP is for that quarter, as the Commerce Department does as more data comes in. But the general picture is we've had, since about 2000, a period of relatively high stock market valuation relative to this longer term average. Another way that you could measure the stock market relative to GDP is to use the Wilshire 5000 stock index, and I believe that data on this is also available in Fred, and otherwise here they're using the same data from the flow of funds. And what you notice is that using the Wilshire 5000 and the flow of funds data in red, you get very similar pictures about the stock market value relative to GDP. Then we have Shiller's cyclically adjusted price earnings ratio. I'm going to be showing you in some detail where we get that from. This is something that goes all the way back to 1881. So you see that graph here. We have a long run mean here, and we see the same phenomenon that for most of the last 20 years, we've been well above that long run mean. Now, a third indicator that is being shown from this Advisor Perspectives website is Tobin's Q. Again, they're telling you how they calculate the Tobin's Q here. And we see this, they've extended it back to 1900 using other data. I can show you that this earlier data is actually available on a website of a financial advisor named Andrew Smithers in the United Kingdom. So if you look for Andrew Smithers, Tobin's Q, you can actually get a spreadsheet with these data, and it actually carries through with this same calculation. The again, for the third time, we have this phenomenon that the last 20 years, this indicator seems to have been high relative to its historical mean. So when we look at all of these indicators, we can put them together. They don't do the stock market relative to GDP all the way back to 1900. But we have, though you could get at least back to 1929, but here what we see is we're going to ignore this Cressmont PE from its geometric mean, because all these people like to put their brand names on stock market indicators, but let's ignore them. So this website, Advisor Perspectives, calls Shiller's CAPE, they call it PE10, and this is Q ratio. And what I want to emphasize about this graph is when they say it's deviations from its geometric mean, what they have done is taken the logarithm of these series and subtracted the mean off. And so this is the deviation of each series in logarithms from the mean of that series in logarithms. And so what we notice, so these are basically, roughly speaking, percentage fluctuations in the series away from the mean. And that's why you see the percentages here. And what we see is that all of these series, these three series, give, I mean, there's some differences here in terms of how they're doing. But they give a very similar picture about which times are above mean and which times are below mean. And certainly, as we've mentioned multiple times, the last 20 years have been a period where almost all of the time, except for the depths of 2008, 2009, these series have been above their means. So that's really the question. Well, I said we can, the article I assigned for this class makes the same type of point using arithmetic averages, I believe. They're taking the current value as compared to the full period average. So they take each series, compute the average of each series individually, subtract that from the series, and then plot the deviations from the average for the various CAPE, market cap to GDP, Tobin's Q, and Hussman's PE, which, as I said, we'll ignore. And so you could see market cap to GDP starting in 1952 and Tobin's Q starting in 1952. And we see that these series, again, give very similar pictures. And if we zoom in on the last 20 years, we have, it's as if we've had 20 years, or I say here 15 years, but more relevant, it seems almost 20 years has the stock market been overvalued. If we simply use the logic that the stock market is high relative to its long run mean based on these indicators, then we would have spent the last 20 years saying, oh, the stock market's overvalued. And the stock market has given very nice returns over the last 20 years. So if you were speaking to a client, they might get a little tired of hearing you say the same thing over and over, that the stock market's overvalued. So one test or one concern that people have about the stock market valuation is, well, what do these valuation metrics mean for stock market returns going forward? So the article that I assigned, they started running regressions. So each time when they run a regression, they take an indicator, and that's on the x-axis. So one is an average of dividend yield and earnings yield. And they look at what happened to the subsequent return on the stock market over the next year. and what happened to the return on the stock market over the next 10 years. And in each time that they run this regression, there seems to be some predictive power. There is a slope to the line. Okay. But what's more important is each time they run this regression, the explanatory power in terms of the R squared seems to get higher, like quite a bit higher, if we go from 1 year to 10-year returns. So we have an R squared that's not so different from 0 in this case. But here we're explaining, in terms of R squared, almost a third of the variation in total returns over a 10-year horizon. And so this is a point that gets a lot of attention. In terms of it seems that this indicator is useful in forecasting returns over the next 10 years. We could do the same exercise again with a different model, the dividend yield plus growth. We can discuss this later. But you see the same phenomenon. You have a return over 1 year, the next 1 year, return over the next 10 years. And we have a very low R squared on the 1 year. So these indicators are not so useful for forecasting returns 1 year in advance, but they appear to be quite useful in terms of forecasting returns over a 10-year horizon. Maybe the last one we'll do is the Shiller CAPE. We put that, actually, they're putting the earnings yield, which is the inverse of the CAPE here, and they're running the regression. So when the earnings yield is higher, that means CAP is lower, you get a higher return. And again, we have this phenomenon of an R squared of about a third. So each time we run these regressions, we're getting the same picture that these benchmarks appear to help us forecast 10-year returns on the stock market. And they're actually now showing in this chart, if you use 4 different indicators, 1 over CAPE is like a 10-year moving average of earnings over the value of the market. Then we could just have earnings over the value of the market. We can have GDP over the value of the market, and we could have dividends over the value of the market, and we could run regressions using these indicators at time t to forecast returns 1 quarter ahead, 1 year ahead, 2, 3, 4, up to 10 years ahead. Dividends lose their explanatory power, but the other 3 indicators that we're focusing on appear to be useful in forecasting longer horizon returns, and their usefulness grows with the horizon. You can see the R squared that they're finding in these regressions is getting close to 0 in the short term, but going to be quite high, up near a third over the 10-year horizon. And so we can argue which one we like best, but maybe they're equally useful. All right.